Okay, today we're going to look at lesson 10.1. We're going to be talking about properties of logarithms. So we're going to start with task 1, and it says investigate the properties of logarithms numerically. Scientific calculators have a log button and a ln, which is natural log button, that can be used to find decimal equivalents or approximations of logarithmic expressions. Use a scientific calculator to evaluate the expressions in each set. All right, so it's made a table here for us. It says, what is the value of each logarithm shown in the table? So it says set A. Okay, so these are our logs. And remember, if there's no base, we assume that to be base 10. So we can assume that set A has base 10. Set B has ln, and anytime we have ln, we assume that to be base E. And since we don't see a base here, we know that's base E. So we can use our graphing calculator to evaluate these. And remember, log, if it's base 10, you can use the button here on the left. If it has any other base, you have to go up to the math button and use the change of base up here. But since these don't show a base, we assume that to be base 10. So log of 1, I can evaluate that by plugging it in. So that's going to be 0. Log of 10. And remember, base 10 to the 10th. So those 10s cancel, and that's why that's 1. And then log of 10 to the 4th. And that's just going to be 4, because again, the base 10 and this 10 cancel, and that leaves the exponent here. So 0, 1, and 4. 0, 1, and 4. Now let's evaluate ln. So this is our natural log. So ln of E. Remember, E is right here above divide. You can think of it as above the division button, or it's right under the pi button, because those are both irrational. So, and this is going to be base E of E, so that would be 1. And then ln of E to the 5th. And that would be 5. And again, the base E and the E, the ln E and the base E cancel, so that's why that's 5. And then ln 1 would be 0. So this is going to be 1, 5, and 0. All right, so you can see anything to the 0 power is 1. And remember, logarithms are inverses of exponential. So hopefully we'll look at that a little bit more, and you'll see that hopefully that makes sense. And then, of course, the base 10 and the 10, anything to its self is going to cancel, and that's going to leave just 1. Again, this base 10 and 10 here cancel, so that's why that's 4. And the E's cancel, so that's 1. And then the E's cancel again, so that's 5. And then E here, ln E of 1 is 0. Again, anything to the 0 power equals 1, so that just kind of goes in reverse, very similar to up here. All right. It says match each expression in set A to its equivalent expression in set B. For any expressions that do not have a match, write an inequality statement. All right, so log of 1, that was the same as natural log of 1. So those were equal. And log of 10, so those base 10 would be the same as natural log of E with base E, and those would also be equal. So you can see this equals 1, and this one also equals 1. And then there's only 2 left. The 2 we have left is log of 10 to the 4th and log of e to the 5th. And you can see that's 4 and this one's 5. So log of 10 to the 4th and log of e to the 5th. We can say that this one is less than, this one's 4 and this one's 5 here. So we can say that that one is less than this one. And that's just comparing expressions to see if they are equivalent. How can you check the results of evaluating the expression in set B? Well, you could just use your calculator to double check those. All right, it says use your method to check the results for your expressions in set B. All right, so again, if you want to just evaluate these, we may be able to go ahead and look up through here and see. This one is 1, 5, and 0. So this one's 1, 5, and 0. And then e to the first, if you want to evaluate what the e to the first is, you can do e. Let's clear this off here. All right, so e raised to the first. Remember, anything to the first power is just going to be itself, so that one should just be e, which we know is approximately 2.7182. And then e to the 5th. E to the 5th is going to be equal to e to the 5th. And e to the 0, anything to the 0 power is equal to 1. So we really didn't need to plug those in your calculator. This is just simply talking about basically properties of exponents. All right, it says what general statement seems to be true about the expression of log of 10 to the b power? So log base 10 of 10 to the b power is going to equal b, because again the 10s cancel out. And then it says what general statement seems to be true about the expression natural log of e to the a? So this is just going to be equal to a. All right, that's all for task 1. If you have any questions, let me know. 10.1, task 2. Investigate the properties of logarithms graphically. Graphing calculators can be used to graph and analyze functions involving common logs as well as natural logs. Consider the graphs of y equals log of 2x and y equals log of 2 plus log of x. All right, so if you look at the graphs, these both look like they are approaching. They have a graph here where they are approaching the y-axis. So I have a vertical isotope at x equals 0, and it would cross at, let's see, if this is 1, then that would be 1/2. So these look like they are the same function. Okay, so the graphs appear to be the same. All right, it says graph the functions together on a graphing calculator. Use the table feature to compare the y values of the two functions. All right, so if we graph these, go to y equals, and let's graph log of 2x. And then scroll down and let's graph log of 2 plus log of x. All right, when we hit graph, okay, I'm only seeing one function, so it's probably the same. So if I go to my table of values, like it tells me, use your table feature to compare the y values. So if I scroll down through here, I can see that the y values are exactly the same. Okay, so these two functions are equivalent. So they are the same. They're not written exactly the same way, but they are equivalent, which means they're basically the same. All right, so it says write two other functions that you believe have the same relationship. Okay, so if we want to use another function like this, maybe we try log of 4x and then log of 4 plus log of x and see what happens. Okay, and then it says explain your results. So if we go in here, let's just change this to a 4. And let's change this to a 4. And let's hit graph. All right, if we go to our table of values again, we can see the exact same thing. So those two functions also are equivalent. All right, it says what general statement seems to be true about functions of the form y equals log of b times mn. All right, so you could rewrite this as log of b of m plus log base b of n. So this is one of the properties of logarithms that's very important. So if you have the same base here, okay, multiplication goes to addition. And if you remember, exponent properties are very similar to this. So this is the inverse. Logarithms are the inverses of exponentials. So the properties should be somewhat familiar. All right, so when you're multiplying, you can expand it, and that can be turned into addition. All right, if you have any questions about task 2, please let me know.